All right, so we've learned how to write electron configurations using the periodic table. But so far, we've only worked an example, phosphorus, that required us to put electrons in s orbitals and p orbitals. Now we need to work an example that requires the d orbitals as well, so that we can learn how to write those into our configurations. I'm going to have us work an example for iron. Before we get started, I just want to remind us of a couple of trends and patterns we can use in the table to help us. The first one is that the energy level, or the big number in our configuration, will equal the row number, or the period number. So row 1, we are in the first energy level. Row 2, we're in the second energy level, third, fourth, fifth, etc. The second pattern I want to point out is that we have these blocks that we've blocked out and color-coded on our table that tell us what orbital type we will be adding to. So are we putting things in a round spherical s orbital, in a dumbbell-shaped p orbital, in these funkier shaped d orbitals, or later we'll see in these really funky shaped f orbitals. And finally, we can count each tile on the table in order to help us count the electrons we need to add. So let's go ahead and get started. We've got 26 protons in an iron atom, and therefore for a neutral iron atom, we will also have 26 electrons. So let's put those 26 electrons in their places. To make things faster, I'm not going to switch back and forth between large text and little text. So if I type something like 1s2, just know that that second number should be much smaller than the big number over here. Okay. Always start with your hydrogen up in the corner. Go ahead and write down the energy level, 1, the orbital we're going to put the electron in, s, and count up how many electrons will fit in that orbital. The first electron will go in that orbital. The second electron will also go in that orbital because we're still in the first row, and helium is still in the s block, hence it's colored in blue. So 1s2. Then we're going to wrap around to lithium. We're in the second row, so the second energy level, still in an s orbital, and we can fit 2 more electrons there. So we're at a total of 4 electrons right now. Go directly across, and we've landed on the p block, where we will start to put our 5th electron in. So we are in the second energy level in the p block, and we can fit 1, 2, 3, 4, 5, 6 electrons in those 3 different p orbitals in the p sublevel. Okay. Come down here to sodium. We're now in the third energy level, still in an s block. We can put 1, 2 electrons there. Go across the row. We land on aluminum. We're in the third energy level in the p block, and we can fit 1, 2, 3, 4, 5, 6 electrons there. I need to stretch this out. Okay. Wrap around, we land on the 4th energy level, and we're in the s block, and we can fit 1, 2 electrons. If we count our second numbers, which in most configurations would be the small numbers, then we will see that we've so far added 2, 8 in total, 10 in total, 16, 18, 20 total electrons so far. Now here's where things get a little interesting as we move into the D block. We've been saying that the energy level is equal to the row number. And for the S block and the P block, that is 100% true. However, the D block is an exception to this rule. It's actually the row number minus 1. So if we're in row 4 right here, the energy level we're adding to is not actually the 4th energy level for the D orbitals. It's the 3rd energy level. 4 minus 1 equals, of course, 3. This is because we used to think the d orbitals were further away from the nucleus of the atom than they really were, that they were up in the 4th energy level or the 5th or 6th or so on. And we now know that they're actually closer and lower in energy than we originally thought. And so we have to subtract 1 from the energy level to account for that. All right, important thing is row minus 1. We're going to add to d orbitals, of course, because this is a d block, and we're going to go 1, 2, 3, 4, 5, 6 electrons